So here we're looking again at factorizing fully this term, and it's a bit strange to factorize this right as we look at it. I remember factorizing means we need to put it into brackets, so when I look at this I'm trying to think about things that I can pull out that every single one of those terms shares. But if you pay close attention, we might notice that some of these are like terms. So we've got 17, a b to the 3, and we have minus 8, a to b to the 3. Now these are like terms because the a's both have a power of 1 and the b's both have a power of 3. So my first step here would actually be to combine the terms, if I can. So it won't always happen, but in this case we can combine the like terms. So 17 minus 8 gives us 9ab to the third, and we're left with this term, 6a3b. So now that I've simplified it, I'm going to look at now factoring it. And remember, factoring is putting it into brackets. So here, I don't see any obvious quadratic with just x squared, so I might think, alright, it might just be one pair of brackets. So I'll put in one pair of brackets and ask myself, is there a number that 9 and 6 share that I can pull out the front? Well, if we think about this, that's 3 times 3, and this is 2 times 3, so they both have a 3, and we can pull the 3 out the front. So we'll pull a 3 out the front. And the next thing I'm going to look at then is an a. So this term has one a, and this term in fact has 3 a's, so I'm going to pull out the smallest number that I have. So the most I can pull out in this case is just 1, because I only have 1 to pull out from this first term. And I'll look at the b's now. Similar situation. I've got 3 b's here, and I've got only 1 b here, so the most b's I can pull out is 1, because that's the most that one of them has. So if I've pulled out a 3ab, I can ask myself, well, what times 3ab would give me back the 9ab cubed? Well, there's the 3 times 3 that I need to get to the 9, so I know I still have a 3. The a, there was just one of them, and I've already pulled it out, so there's none left. There were 3 b's, and I've pulled one out the front, so in fact now there's going to be 2 b's. And if I times those together, 3 times 3 gives me 9, a gives me a, and b times b squared gives me b to the third. Looking at the second term here, I need a 2, because 3 times 2 will give me the 6. I've got one a out front, so I need to have 2 a's in here, so that a times a squared will give me a to the third. And there's one b out the front, and I only need one b in that term, so I don't need to write it, because it will already be there. So this is my final answer, 3b squared minus 2a squared with 3ab out the front. So here we've factorized it fully after combining the like terms. Now a similar problem that you can sometimes see is just a different style of factoring here. In this case, we can check for like terms, and there's 2x's and 3x's, 5y's and 4y's, so in fact no like terms here. So we will not combine them, and we'll think instead about simply factoring it. So like we did in the previous problem, we'll use one set of brackets, and I'm going to think about what is the minimum number of things that these share. So in terms of x's, how many x's do I have at the most that I can pull out? Well, this guy's got 2 I can pull out, and this one has 3, so I can't pull out any more than 2. I'll put the x2 out front. And for y's, this one has 5, and the second term has 4 y's. So the most that I could pull out would be the 4. I can't get any more than 4 out of that last term. Now that I've got this out the front, I can think about, well, if there's an x squared out front, do I need to have an x squared in there? Nope, because I've pulled both of the x squareds out. They're already out the front. And if I have 4 y's but I needed 5, that means I need one more y in there. The minus sign will stay where it is. If I have 2 x's out the front, how many have I pulled out of here? Well, I've pulled 2 of them out, so what's left? There's still 1 left. And I've pulled out 4 y's, and that in fact is all of the y's that I have, so I can't leave any behind. So this is my final answer. And to check it, you can think about expanding it back out. So if we wanted to check, we could just expand it back out. X squared 4y times y is going to give me x squared y to the 5. And timesing it to the second term, x squared times x will give me x cubed. The negative stays there. And y4, well, there's no y to times it to, but it just goes in there. y4, which is exactly what we had at the start. So we know that we're done, and we've done it correctly. However, don't be confused about going in a circle. Your final answer was this step along here. This was just checking your work to make sure you've done it correctly.